When we talk about chemistry and chemical reactions, people tend to think about things that burn and explode. And even if that's fun, it's first when we understand how a reaction happens and learn to control when it happens that we can create new, interesting solutions that help us move forward. And today we're talking about chemical reactions.
If it wasn't for the fact that things can change form and be converted into new things, the world would pretty much come to a standstill. You could even say that chemical reactions are what drives the world forward.
An explosion caused by a chemical reaction, the definition is that it's a chemical reaction occurring very, very fast. In fuels, for example, we want to take the energy stored in a fuel, and when we burn it, it releases a lot of heat, and that heat in turn can drive an engine, for example.
Our explosion in the beginning is actually a simplified demonstration of how a traditional combustion engine works. We have a fuel, a liquid that is highly flammable, and when the fuel is ignited with a spark, it reacts with the oxygen in the air, which creates a small explosion that exerts a pressure on a piston. So by controlling when the reaction that causes these explosions occur, we can convert the energy in the fuel to kinetic energy that moves the vehicle.
But first, let's talk about what a chemical reaction is. Just because there's an explosion doesn't necessarily mean there's a chemical reaction happening, and this was not a chemical reaction.
Things can also explode without involving a chemical reaction, so it is important to define what a chemical reaction really is. All substances can occur as either solids, liquids, or gases. When a substance goes from, for example, a solid to a liquid, the molecules still remain unchanged. Instead, the substance undergoes a physical change. This is not the same as a chemical reaction. In this explosion, we had liquid nitrogen, which has a boiling point of -196 degrees centigrade. This is why we see all the smoke, as it turns to gas incredibly fast at room temperature. Because the bottle was closed with a cap, the increasing pressure inside eventually caused it to explode, but we still had the same molecules. A chemical reaction, on the other hand, happens when two or more elements or molecules react, and the resulting molecule or molecules are different from what we started with. Chemical reactions are involved in everything, from photosynthesis in plants to the development of new materials and, as we saw before, what powers our combustion engines.
The invention of the combustion engine was, of course, huge, but it wasn't completely free from problems.
The traditional combustion engine is powered by a chemical reaction involving fossil fuels that also results in end products with negative effects on both humans and the environment. Fossil fuels are called fossil because they're formed from the remains of animals and plants that died millions of years ago and that have since been buried deep underground and therefore not been part of the natural ongoing cycles of molecules that happened above ground now. When these fuels are brought back up to the surface, they alter the current balance. If we take a look at the chemical reaction involved, we can see why. Octane in gasoline reacts with oxygen in the air, and in addition to the energy that is released, we also get water and carbon dioxide. Carbon dioxide is what is called a greenhouse gas. Greenhouse gases are natural and necessary gases in the atmosphere, but as a result of our extensive use of fossil fuels, we're adding so much more carbon dioxide to the atmosphere that it is affecting the global climate.
Most importantly, we want to use reactions for a specific use, but also without messing up with the environment.
Researchers are trying to find better and more environmentally friendly alternatives to the fossil fuels used traditionally in these combustion engines.
A perfect fuel is something that is easy to handle, easy to store, it is non-toxic, and it releases a lot of energy when we want to. And it shouldn't produce any harmful substances.
One example that is very close to my heart is the fuel cell car that in fact operates by using hydrogen as the fuel.
All right, so we thought it was time for another explosion so that you stay awake. And what happened here, that was actually a chemical reaction.
That explosion was the power of hydrogen gas reacting with oxygen. With the help of an igniting spark, we get a rapid and powerful reaction as hydrogen and oxygen react, and the end result is water. Many scientists are now seeing great potential for this relatively simple chemical reaction to replace the fossil fuels that we are so dependent on today. But hydrogen gas is not freely available to just collect. It needs to be produced. So where do we get the hydrogen from then? Well, we already know that hydrogen is one of the elements in water, H2O. By adding an electric current, we can force the reaction to go in reverse and separate the hydrogen and oxygen again.
Imagine if you could drive around in a car that goes only on water.
So, similar to when we charge a battery, we can use electric power to drive a chemical reaction to split water and produce our hydrogen fuel. It may sound counterproductive to use energy to produce energy, but a big challenge today is how to make use of the energy from renewable sources and then store it in a way that it can later be used in, for example, vehicles. The idea here is to use renewable energy sources like wind, water, and sunlight, and at times with, for example, lots of sun and strong winds when we have high energy production, that excess energy can be used to produce the hydrogen gas. The end result is that with these so-called fuel cells, we would only really need a couple of fairly simple chemical reactions to go from water to produce our fuel, the hydrogen gas, and then back to water again as the final product in the explosive energy generating reaction. But it should also be said that this is only one of many ideas researchers are working on in order to harvest the energy from chemical reactions in the quest to find new and more environmentally friendly energy solutions for the future.
So chemical reactions are, like we said before, what drives the world forward. And it's not just about vehicles and machines, it's in our own bodies as well. The energy that we get from the food that we eat gets converted through chemical reactions into everything that we need to survive. So to sum things up, an understanding of how and when chemical reactions occur is both important when it comes to understanding how the world works, but also when it comes to developing new and improved solutions for the future. So thanks everyone for watching today.